Let's look at tutorial question on clutches. So for question 1, it says that a single plate clutch effective on both sides is required to transmit 40 kilowatt of power at a speed of 3000 revolutions per minute. Coefficient of friction is given as 0.25. Ratio of diameters, this is basically talking about your outer diameter divided by inner diameter. That's your diameter ratio, which is given as 1.25. Maximum pressure or lining pressure is given as 120 kilopascal. Assuming uniform wear, we have to determine the outer and inner diameters of this frictional surface, and finally to find the axial thrust that needs to be provided to the spring. So a few things that you need to keep in mind is that it is effective on both sides. So what this means is that we've got two frictional surfaces. The diameter ratio is simply meaning the outer diameter over the inner diameter, which is given as 1.25. And then last thing is that we're looking at a uniform wear case. So what we do is we list down all the variables that are given to us. So power was 40 kilowatt, speed was given as 3000 revolutions per minute, converting that to angular velocity. So 2 pi upon 60, we get our angular velocity as 314.16 rads. Your diameter ratio, which is your outer diameter divided by your inner diameter, is given as 1.25. So therefore your outer diameter, which is capital D, is equals to 1.25, inner diameter, which is small d. So this is important. The power is given as torque times your angular velocity. So therefore torque, you can find your torque, which is nothing but power, which was 40 kilowatt, divided by your angular velocity of this. So your torque equates to 127.32 Newton meter. The next thing that we'll do is, we know that we're given a uniform wear case. So for uniform wear case, this is the formula for finding torque. This is the formula for finding torque. Now what happens is, as mentioned in your lectures, there is a invisible n that is in front of this equation. So whatever is contained within the brackets is multiplied to n, and n is the number of frictional surface. So in this case, the question says that it is effective on both the sides. So therefore n is 2. Your torque we have calculated to be 127.32 Newton meter, which is over here. Now substitute all the variables that are known to us. So coefficient of friction was 0.25. Maximum lining pressure was given as 120 kilopascal. So small d is your inner diameter divided by it, and then in place of your outer diameter we can substitute this over there. So capital D is nothing but 1.25 small d whole thing squared minus d squared. So once we evaluate this, so 1.25 d whole thing squared minus d squared, we get 0.5625 d squared into all of these. So if we further simplify, so your torque 127.32 is equals to, evaluating all of these, so 0.25 times pi times 120 kilopascal divided by 8 times 0.5625 times 2. You should be able to simplify the above expression to this. So 127.32 is equals to 13,253.59 d cubed. D cubed is nothing but 9.606 times 10 power of negative 3. Solving for your d, which is your inner diameter equates to 213 mm. And once we have this, your outer diameter is simply 1.25 times your inner diameter. So 213 times 1.25, you get your outer diameter to be 266 mm. Now the next thing is we have to find the actuating force. So you need to understand that whenever we calculating actuating force, it is independent of the number of frictional surface that are given to us. So actuating force again for uniform wear is given as pi p max small d, which is inner diameter divided by 2 multiplied to outer diameter minus the inner diameter. So substituting for your outer and inner diameter, we obtain our actuating force of 2.13 kilonewton. So just once more, it's a uniform wear case. It is effective on both the sides. So therefore n is 2. Now what happens is your diameter ratio. Your diameter ratio is the outer diameter divided by inner diameter, which is given as 1.25. So substituting for that and then simplifying, you should end up with these values. Question 2 is dealing with cone clutches, and this solution is specific to this type of problem only, in the sense that the mean radius of the cone clutch is given. So in this problem, what happens is the mean radius of the cone clutch or the cone is given as 200 mm, right? The cone angle is given as 8 degrees. The maximum lining pressure is 0.7 megapascal. The coefficient of friction is 0.2. The cone face is given as 75 mm. We have to determine the actuating force, the torque, and finally the frictional power that can be transmitted if the cone clutch rotates at 600 revolutions per minute. So for this type of problem, just because the mean radius is given, the manner in which we solve this problem is slightly different. So this equation, this and this can only be used if this type of problem is given to you. So what happens is your actuating force is given by P max pi b d sine alpha. So P max is your lining pressure, which was 0.7 megapascal pi, and B is the cone face, which was 75 mm, converting that to meters. The radius was given as 200 mm, so diameter is 400 mm, converting that to SI units. And your alpha, the cone angle, is given as 8 degrees. So substituting everything into this equation, you get your actuating force to be 9,181.73 newtons. Now what happens is the torque, again this formula can only be used when this specific type of problem is given for cone clutches in which the mean radius is specified. So what happens is your torque is nothing but coefficient of friction times your actuating force times the mean diameter divided by 2 sine alpha. So substituting for all of these values, you get your torque to be 2639.94 Newton meter. And then lastly, power is again standard formula. Power is nothing but torque times omega. Torque we have calculated already, and omega is your angular velocity, which is given as 2 pi n upon 60, and at a speed of 600 revolutions per minute we can calculate our angular velocity. So torque times your angular velocity, you get the power that will be transmitted at that particular speed is going to be 165.81 kilowatt. So again, you need to be mindful that this equation 1 and equation 2 can only be used if the problem on cone clutches is given in this manner, in which the mean diameter or the mean radius is given, the cone face is given. Otherwise we can use previous type of equations, but we need to introduce sine alpha component over there. Now let's look at the last question for this tutorial, which is dealing with centrifugal clutch. It says that a centrifugal clutch is to be designed such that it is able to transmit 20 kilowatt at a speed of 100 revolutions per minute. Sorry, 1000 revolutions per minute. In total, there are 4 shoes with subtended angle of 60 degrees. The inside radius of the pulley rim is given as 150 mm. The distance from the center of gravity is given as 120 mm. The coefficient of friction is specified as 0.25. The maximum pressure is 100 kilopascal. So what we supposed to do is we have to determine the mesh of the shoe. So again, these equations that we are using, we are just simply looking at a lecture example with some modified values here and there. So what happens is the power is given as 20 kilowatt and the centrifugal clutch is rotating at 1000 revolutions per minute. The inside radius of the rim is 150, the distance or the center of gravity is 120 mm, the coefficient of friction is 0.25. So power is nothing but torque times omega. So power was given as 20 kilowatt. What we do is we can find omega. Omega is your angular velocity, which is 2 pi n upon 60. So 2 pi times 1000 divided 60. So your angular velocity is 104.72 rads per second. So your torque is nothing but the power divided by your angular velocity. So your torque equates to 191 Newton meter. Now the next thing that we do is we need to calculate our net force, or the net force acting on this particular centrifuge, on the shoe of the centrifugal clutch. So this F net is again from your lecture notes. So your net force is simply the centrifugal force minus the spring force, because all of the shoes are attached to the spring. So your net force is nothing but 7/16 m omega squared r. M is the mass of the shoe, right? So mass of the shoe. Then what happens is omega is your angular velocity, and r here is the center or distance to the center of gravity. So over here this r is nothing but 120 mm. So substitute everything. So 7/16. The mass, value of mass we don't know, so leave it as it is. Angular velocity was 104.72, so squared, and then times the distance to the center of gravity is given as 0.12, which is 120 mm. So once we evaluate this, we end up with the value of 575.73 m newtons, where m is the mass. So we are solving for m. Now we leave it as it is. So your net force is this. Now this equation is again from your lecture notes. The torque that is acting is nothing but equals to n mu f net r. N over here is the number of shoe that we have, right? Mu is the coefficient of friction, f net is the net force acting on each shoe, and r is the radius or the inside radius of the rim. So number of shoes that we have is 4, because it says that there are 4 shoes. There are 4 shoes. So we will substitute for that in this. So number of shoes is 4 times coefficient of friction is given as 0.25 times your f net. F net is 575.73 m times the radius or the inside radius of the rim. The inside radius of the rim is given as 150 mm, so in SI units, which is equals to your torque, and torque is nothing but 191 Newton meter. So if we make m the subject of the formula, so your torque 191 Newton meter divided by 4 number of shoes times your coefficient friction times your this value times the inside radius of the rim, we obtain that the mass of each shoe is roughly 2.21 kg. So again, these equations are obtained from your lecture notes. When you look at your lecture notes on your clutches, and in that we've got a section on centrifugal clutch, so these equations are there. So F net is the difference between your centrifugal force minus the spring force, so we can use this straight away. So 7/16 m omega squared r, and then this is again given, so torque is equals to n mu f net r. N is the number of shoes, so in this case it says 4 shoes, so substitute. So finally you get mass of each shoe to be 2.21 kg.